this is Himabindu from the Department of CSIT. Today in this video, I would like to explain about the left derivation tree and right derivation tree. So in the previous video, we discussed about the derivation tree and what are the types of derivation trees. We have the leftmost derivation and rightmost derivation. So here in this video, I would like to explain about the derivation tree. What is meant by derivation tree and how many types of derivation tree we have for the context-free grammar. And we will discuss more about this derivation tree. So what is meant by derivation tree is nothing but it is a graphical representation. So graphical representation for the derivation of the given production rule. So in previous videos we discussed about the production rules derivation. So here we have one input string and for that input string we have to derive the equation. We have to derive the input string from the production rules. So how to derive that we have already discussed in the previous video. And now this is the graphical representation. So derivation tree is nothing but it is a graphical representation. So graphical representation of derivation. So in derivation, leftmost derivation and rightmost derivation, we discussed about the production rules and how to implement the derivation in the context-free grammar. So here that is the after derivation, how to add the parse tree or we have how to add the derivation tree for the derivation. So here, so it is a simple way to show that how derivation can be done to obtain some string from a given set of production rules. So what is meant by derivation? So we are taking some production rules. In that production rule, we have to substitute the productions. So based on our input string, we have to substitute the production rule. So after finishing all the derivation part, we will get the input string. That is, input string is having the only terminals. So whenever we have the non-terminals, we have to replace it with the terminals. So a parse tree contains the following property. So it is also called as parse tree. So derivation tree is also called as parse tree. So what are the properties we have for the parse tree? In the sense the root node. So and what is meant by root node? So whenever we are taking in derivation, we have taken the start symbol. So start symbol production rule. So in that start symbol production rule, what we have taken is the left hand side part of the production rule is taken as the root node. And the derivation is read from left to right. After completing the derivation part, we will represent it with the graphical tree, and in that one we will read that string from left to right. We will show that in the next example. And the leaf node is always a terminal node. So finally, what are the leaf nodes are nothing but in the graphical representation of derivation tree, all the leaf nodes are terminals. So like input symbols. And the interior nodes are always the non-terminal nodes. So middle of the parse tree, whatever the contents in the parse tree, non-terminal nodes are the interior nodes. So we will discuss it more with the example. So this is about the properties of the parse tree. So first one is the root node. So usually root node is nothing but a start symbol, and the derivation is read from left to right, and the leaf node is always the terminal nodes, and the interior nodes are always non-terminal nodes. So these are the properties, and the derivation tree is a graphical representation, and it is also called as parse tree. And the derivation tree example. So here we have taken one example. For this one we have the input string. So here these are the production rules, and we will take one input string. So what is the input string? We will take A, B, B, A, B, B, A. So this is the input string. We have to derive this input string from this production rule. So first step, what in the derivation also we discussed, the first step what we have to do in the sense, we have to write the production, we have to write the grammar first. So grammar is nothing but we have the 4 tuple. In that one, first one is a non-terminal set, so that is represented with the V, and terminal which is represented with the capital T, and production rules, these are the production rule, and what is the start symbol. So these are the 4 tuple representation for this one. So by seeing these production rules, we can write the word non-terminal set. So non-terminals, so what are the representations of capital letters or all the non-terminal set. So S, B, A, B. So these are the non-terminal set. And terminals, so what are the input symbols, what are the small letters which are involved in this production rule, all are called terminals. So what are the terminals? A, B. So other than that, no small letters are there. So these are the terminals, and these are the production rules, and this S is the start state. So this is about the grammar for this production rules. So we already find the grammar, and after that how to derive a string. So this is the input string. So first step to draw the derivation tree, in the sense we have to derive that string. So how to derive in the sense? So first start state we have to take, and what is the start state, and we have to check for the input symbols also. So here the A is the start symbol, so A is the input. So in that one, so we have 2 production rules for the start state S. So we have to take this A, B. So why? Because the input is starting with the input symbol A. So, and for this production rule, we have to substitute the non-terminals in the right hand side. So how to substitute? We have, what is the next step? We have to substitute this non-terminal. So here I will write B tends to which one I have to substitute. So here AS is there. We will write this AS. Why? Because the next input symbol is A. So here next symbol is A. So here, we have to take B. So B production rule. So here we have to write A, B, B. Why? Because the input symbol is next A, and here there is a production rule with the input symbol A is there. So here we have to substitute this A, B, B. So let me write that A, B, B. And here we have the 2 B's, and in that one, which one I have to substitute, in the sense B. So here, is there any B with the B? So here next input symbol is B. So here, is there any B in the sense BS is there? So I will write this A, B, S and B. So here I have S, and here B is the next step. So here again what we have to do? S we have to substitute. So S tends to next input symbol is B. So here B we have the BA. So in that one I will write BA. So A, B, B, A and remaining B is there. And here we will write A tends to next input symbol is A. So here A I will substitute. So A tends to A is there. So A, B, B, A and B is there. So B instead of B, what we have to write? So A already there, we require B, B, A. So for this one B, B, A, B is, so B tends to B, S I will write. So A, B, B, A and B, S. So after that what we have to substitute? S. So S tends to what we require again B require. So S tends to BA is there. So BA we will write. So A, B, B, A, B, B and A. So again A tends to A. If you write A tends to A, we get the input string B, B, A, B, B, A. So this is after finally deriving this input string from the production rule, we got the input string. And here with this production rules, step by step, we can draw the graphical representation of this derivation. How to write this? The first property is the start symbol is the root node. So what is the start symbol here? S. So S, we will write the S. And here for what we have taken the production rule A, B. So we have to write, we are writing the non-terminal nodes are in the circle and terminal nodes will leave like that. And what we have substituted, instead of B, we have written A, B. So here, instead of B, we have written like this. So here, again, a B, instead of B, we have to replace it with the A. So already A is there. So BS, we have to write the BS. BS. BS is there, and BS, after BS, we have to write S. Instead of S, we written BA. So BA we have written. So and after that we have instead of A, we have written A, and we are taking the B, and B, instead of B, we are writing BS. So and instead of S, we are writing B, A, and A, we are writing this. So this is, we are reading the input from, and next property is, this is a root node, and these are the internal non-terminal set, and these are the leaf nodes are all the terminals. And what we have to do from left to right. So here the input string what we have got from this derivation tree. So left to right I am reading A, B, B, A, B, B, A. So this is the input string what we got from the derivation tree. So this is about the derivation tree example. And let's discuss about what are the types of derivation tree we have. And here the types of derivation tree, we have the leftmost derivation tree and rightmost derivation tree. So here it is rightmost. So leftmost derivation tree is obtained by applying the production to the leftmost variable in each step. So here it is equal to the leftmost derivation. So after derivation, we will convert that to a derivation tree. So here we have taken the input string and these are the production rule. The first step is what we have to do. We have to write the grammar first. So in that one, V, T, P and S. So here what is the grammar? So V is nothing but only V symbol is there. So E only there, and T is nothing but A comma B, and P are these are the production rules, and S, instead of S, the E is the start state. So here these are the these are the CFG, context free grammar. And here, and with this grammar we will write the leftmost derivation and rightmost derivation, and by using the input string A minus B plus A. So let's leftmost derivation. So leftmost derivation and rightmost derivation. So first derivation part we will take. So here the input string is A minus B plus A. And here also input string A minus B plus A. And here first derivation part, so E is the start state. So E tends to E plus E. We will take this one. So leftmost derivation. So we already discussed leftmost derivation and rightmost derivation. So in the leftmost derivation part, first step is leftmost non-terminal we have to take. So here the leftmost non-terminal is this E, and for this E we will replace it with E tends to what we require, a minus symbol we require. Is there any production with the minus symbol? We have to substitute that equation. So instead of this E minus E plus E. So after this one, we will write E tends to A and E tends to B. So here E tends to A, we will write, and we will next write this B, and E tends to B plus E, and after that E tends to A minus B. So why? Because we are moving from left to right. So here the leftmost derivation, the leftmost part of the non-terminal we have to substitute. After that next leftmost, and like that we have to move from left to right. And here we have A, E tends to B and E tends to A. So this is about the input string what we got from the derivation. And for this derivation input string, how to write the derivation tree. So leftmost derivation tree. So here the first step is we have to take the root node. In that one, first production rule. So this is the first production rule. After this, we have taken the input string minus symbol. So we require this one. And here we will write A, B and B. So we have to read from here to here. So what is the input string? So input string is A minus B plus A. So this is how leftmost derivation. This is the leftmost derivation tree. And like that we will also write the rightmost derivation tree. So for the same input symbol, we have to take the production rule. So here first step, start state we have to take, and here the rightmost, we have to change the rightmost symbol. So in the rightmost right derivation tree, we have to take the rightmost symbol. So here for this one I am taking E minus E. So and here rightmost. So observe. So in the leftmost derivation tree, we are taking the left side non-terminal. In the rightmost derivation tree, we are taking the rightmost non-terminal. So here instead of this E, we will write E plus E. So because after minus we will write plus. We have the input value plus. So that's why we are taking E minus E plus E. So instead of E we will write. And here again we already got the non-terminal set, and we have to substitute this E. Why? Because rightmost derivation. So we have to replace this rightmost symbol. So here E minus E plus A. And so here we have to write E tends to B. And here E minus this one B plus A. And again E tends to A. And E tends to A minus B plus A. So we already got the input string. And for this one, how to write the derivation tree. So how to write the derivation tree? So first step is, so in root symbol is start state. And what is the next production rule we have taken? So here E plus E, and here this one A, and this one B, and this one A. So we have to read from left to right. So minus A minus B input string, A minus B plus A. A minus B plus A. So this is the input string what we got from the derivation tree. So this is about the simple example of the left derivation tree and right derivation tree. And we will discuss more with the examples. So let us take this example AAB. This is the input string, and what is the production rule of the CFG. So first step what we have to do. So we have to write the grammar for this one. So what is the grammar? So here V, I am directly writing V. So V is a non-terminal set. So A, S, only two S, comma A. And next, What are the input symbols? A, B. And the production rules, and the S is the start state. So this is the grammar for this production rules. And input string is A, B, A. So we have to derive leftmost derivation tree and rightmost derivation tree for this grammar. And we will divide this leftmost derivation and rightmost derivation. First step is for the leftmost derivation tree, we have to derive the input string. And here input string is A, B, A. So first step is what we have to do to derive this. We have to take the A is the input symbol. So here A is the input symbol. We will take this ASS. So here the ASS. After that, leftmost. So what is the non-terminal left hand side? So this is the non-terminal symbol in the left hand side. So we have A terminal, and after that we require A input symbol. So S with the A input symbol, we will take this A. S tends to, so S tends to AS. And here we will substitute this ASS. And here we will write this. So S tends to A, and again leftmost derivation is A. So A tends to what we require, BA. So next input symbol is B. So A with the B input symbol, this is. So we will write A, B, A and S, S. So here after that we have to write already finished this B, A and S we require. So S tends to, so this is the input symbol. And what is the next input symbol? We have the only we require input symbol A. So we already have A and we require only A. So here we will write S tends to ASS. Why? Because so here we already have the epsilon symbol. So we will replace it with ASS with the epsilon symbol. So here, so A, B, A and S, S, S. So 3 S's are there. So we will replace all S with the epsilon symbol. So we will get the input string. Epsilon, epsilon, epsilon. So finally we got the input string A, B, A. So this is the input string, and we will write the leftmost derivation tree. So by seeing this derivation, we will say that first root node is S, and what is the production rule we have taken? So S, S. And after that, we have substituting it A with the A, S with the S, A and S. And after that, we have to write instead of A, we are taking B, A. And after this, S is there. So after that, S tends to A, S, S. And we will write all the S symbols with the epsilon. So by reading from here left to right, we will get the input string. So here what is the input string? So input string is A, B, A and epsilon, epsilon, epsilon. So finally A, B, A. We got the input string from this derivation tree. So this is about the leftmost derivation, and same for the same example we will construct the rightmost derivation. So rightmost derivation tree. And same step what we have to do, we have to take the input string A, S, S. And for this one, so in the right hand leftmost derivation, rightmost derivation, what is the difference in the sense? We have to take the leftmost symbol. So in the production rule, we have to take the leftmost symbol in the LDT, and in the right RDT, we have to take the rightmost symbol. So here A, S, S instead of S, we will write A, S, S. So A, S tends to A, S, S. We will write. And next, oh sorry, A tends to, so S tends to A, S. So A, S. And here the rightmost symbol. So what is the rightmost symbol? This S. So here we have to substitute this S with ASS. ASS. So A, S, A, and ASS. And here again we have, so rightmost symbol S. So here we have to substitute this epsilon and we will write A, S, A, S, epsilon. And for after that, this rightmost symbol is also replaced with epsilon. Epsilon. And we have rightmost, in the middle we have A symbol, so we have to replace. Why? Because instead of this S, we are replacing A. So why? In the sense, in the rightmost derivation, we have to check from right end to left. So that's why in the from right end to left, we have A terminal, A non-terminal is there. We have to substitute this A terminal with the BA. So instead of this BA, we are writing A, S, A, B, A. And here again B is there. And we already got this input string and only the input S non-terminal is there. Let's write S tends to epsilon. We will get the input string as epsilon A, B, A. And finally A, B, A. So this is the input string, and we will construct the same thing with the derivation tree. So derivation tree, this starts with the S symbol, and what is the production rule we have taken? S. And instead of this S, so we have to write this S. Why? Because rightmost derivation, we have to take the rightmost non-terminal. So instead of this S, we are taking A, S. And we have to substitute this S with, we have to take this S with A, S. And here we have to replace this rightmost symbol epsilon, And next step is we have to take the A inputs, A terminal, and we have BA is there, and we have the left non-terminal is S tends to epsilon, So here we will get A, epsilon, A, B, A, epsilon. So after removing the epsilon symbols, what we get? The input string A, B, A. So this is the rightmost derivation for this example, and we will discuss one more example for the leftmost derivation tree and rightmost derivation tree. And here is the same thing. We are taking the input string, and first let's derive the input string, and after that construct the derivation trees. So first step is we have to form the grammar, and V it is having S, A, B. So we have three non-terminals here, and the terminals are 0, 1, and the production rule, and S is the start state. So input string is 0, 0, 1, 0, 1. So and here for the construction of LDT, I am dividing LDT and RDT. So leftmost derivation tree and rightmost derivation tree. So for the same input string, and we first step what we have to do, let's derive this input string from the production rules. S tends to A, only one production rule we have. So we have to take the production rule 1, this is 1. So in the leftmost derivation, we have to take the leftmost non-terminal. So instead of this A, in the input string we have 0. So instead of we will replace 0 input symbol production. So here instead of A, we will write 0A. So 0A, 1B. And here we will write the equation also. A tends to 0A. And next, A tends to, we have the equation A tends to, again we, in the input symbol we have 0. So is there any A with the 0 input symbol? Production rule, only one production rule is there, 0, 0, A, 1, B. And again the A we have, so here already we have input string leftmost non-terminal. So leftmost non-terminal is A. So instead of this A, we will replace the epsilon symbol. So we will get 0, 0, 1. So by replacing A with the epsilon, we have 0, 0, 1 input string. So 0, 0, 1 and B. So here B tends to what we require 0, 1. So is there any equation with the 0 input symbol? So here 0B is there. So we will write this B with the 0, 1, 0B. So and after that we require one input string. So one input string. So input string 1 with this production rule, B tends to 1B. And here 0, 0, 1B, 1 and B. So instead of this B, we already got the input string and we have the B. So we will replace B with the epsilon. We have the input string 0, 1, epsilon. So 0, 0, 1, 0, 1. So we got the input string, and for the same thing we have to construct a leftmost derivation tree. So here S tends to, S is the root node. So here we have the input string and B. So what are the non-terminals are there? We have circling, and those are represented as internal nodes. And here what we leftmost derivation, A tends to 0A, we are replacing, and here also 0A. And for this one epsilon we are taking, and after that we already have 1, and with this B input symbol, first input B and 1 last input symbol is 1 and B, and for this one we are replacing epsilon. So let's read this input symbol from left to right. So here what we got, input string 0, 0. Let's leave this epsilon symbol and read all the leaf nodes. So these are all called the leaf nodes 1, 0, 1. So what we got, the input string from the left derivation tree. So like that we will also construct the right derivation tree. So here the first step is only one production rule is there for the start symbol, and for this one we have to write the right derivation tree. So write in the right derivation tree, which one we have to take? B. So B is the rightmost non-terminal. So we have to replace this B. So how to replace this one? So instead of B, what we have to write? So here we have the two production rules. According to the production rules, we have to take the input string. So instead of B, we will write 0B. So 0B, A1, 0B. And again, we will write this right hand side non-terminals are there. We have to consume all this non-terminal right hand side, and we have to replace it. 1, 0, we already have 1, 0, and last input symbol is 1. So let's write the production rule with the 1 input symbol. So here A, 1, 0, and here instead of B, we are writing 1B. And here we will write this B with the epsilon symbol. And here 1, 0, 1, epsilon. and instead we have only one non-terminal left. So for this one we will write a tends to, we require 0 0. For this one we will write 0a 1 0 1, and here again a terminal is there, a non-terminal is there, we will write a 0 a. So 0 0 a 1 0 1, and here again a tends to epsilon we are writing, so 0 0 epsilon 1 0 1, and here after removing the epsilon we got the input string. So this is how we are deriving the input string from the production rule. So same for this one, we will construct the derivation tree, rightmost derivation tree. So we are taking the input string A, 1, B, and we are writing the rightmost non-terminal. So here we have the non-terminal with the B, we are replacing it with the 0B, and with this B is replacing with 1B and this epsilon. And we have the A input symbol, so with this 0A we are replacing, and again 0A, and again this A is replaced with epsilon. So let's read from left to right. So we will get the input string. So what is the input string? 0 0 1 0 1. So this is how we are deriving the rightmost derivation and rightmost derivation tree and rightmost derivation tree for the given examples. So these are about the leftmost derivation tree and rightmost derivation tree, and these are the examples taken from, and this is about the leftmost derivation tree and rightmost derivation tree in the context of free grammar. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.